Okay, this is my Lego pinball game, which I've made a prototype chassis for out of foam core. So, basically, the premise of it is that the balls come out of that hole up there. They fall down past that thing that spins. There's a piece of plexiglass covering it, by the way. Through all those little pins. And then you gotta try and catch the ball with this. There's two buttons on the front and a volume control. There's the display. 4 indicator lights show like your ranking at the end of the game. There's a ready light and a wait light. So without further ado, let's turn it on. So now that the game's on, you'll see that the ready light is on because everything checked out okay during the self-test, which I'll explain later. You've got two buttons down here. The green one is the start button. The yellow one changes the game mode. I'll turn the volume up so you can hear the beep. Now I'll show you that the game has music. You're not going to be able to hear much of me when the music's playing, so I'm just going to play a quick game without talking. Oh, well, that's embarrassing. Well, I fixed that little problem there. Just a ball jam. I'm going to purposely lose so that you can hear what it says when you lose, or what it does. You need to get 5 out of 10 balls for this round. So that was game mode 2. Game mode 1 doesn't have rounds or levels or anything. It pretty much just, it spins that wheel for the entire game at a different speed for every ball. And essentially, you're just trying to get the highest score you can without missing 5. Because you have like 5 lives. So you could change the display mode by pressing the mode button during the game. That'll show you the number of lives. That'll show you how many balls you've caught. Try to ignore the shadows. Okay, so this time I was on the ball. And yes, that is a pun that I intended. So now I'm going to take the cover off. You may have seen the inside before if you viewed my previous video, but if not, this will be all new to you guys. Okay, I've taken the cover off. Now there is a little problem here. Now that that light sensor is uncovered, it might not operate properly. However, I've got a solution. Because if the game's moved from one location to the other, light might shine down through the glass and into here or into here. I figured that that might be a problem, so I've come up with a solution that manifests itself every time you turn the game on. I'm going to turn it off and watch that sensor right there. In case you didn't notice, that LED flashed on and off a few times, and then the microcontroller read that sensor and recorded the difference between when it's on and when it's off, divided that difference by 2 and made that the threshold. So that way the game will work in different lighting environments. Now let's say there was a problem of some kind, like for instance the wire to the LED got disconnected, or the wire to the sensor itself got disconnected, or something like that. Well, the game will know. The game checks the difference between when it's on and when it's off, and if there's no difference or very little, it'll display an error and show you which sensor is wrong. I'm going to obstruct the sensor, and then I'm going to turn the game back on. And see what happens. Watch the display. Yeah, error 4 means the ball exit sensor is not working properly. If it encounters an error of any kind, the game has to be reset. However, if an error occurs sometime during the game, you can see what your final score was by pressing start. But since this didn't happen during the game, there's no score to display. The same thing happens with that sensor right there. So I'm going to put the camera, you probably might not be able to see this, but you'll be able to see the green light. So yeah, I'll also demonstrate that that thing does the same thing there. I'll put something in there to block the sensor. Notice that the number is different. That helps because if it always said error 4, regardless of which sensor was wrong, you wouldn't know which sensor was not working. So I'll show you the mechanism that gives you the balls. I'm going to turn the machine off and then on again because it tests that thing every time you turn it on. Only balls have to be loaded in the hopper for it to load any. Now let's say that didn't work for some reason. Like, let's say the motor, like the wire was disconnected, or there was a ball stuck in a position that prevented that from turning. I'm going to simulate that by disconnecting the motor, and then I'm going to turn the game back on. Okay, now it's disconnected. That's just that thing turning. Oops. That wheel spins every time the game starts up, just in case it gets in a position where the balls get stuck. However, if it is in the game and it is in a position where the balls can't come out during round 2, I'll turn the music down so I can talk. Watch the wheel. If you wait about 10 seconds or so, it'll start to spin, it'll speed up and then slow down. And then hopefully when the ball comes out, it'll be in a position where the other balls can come out too. And if not, the same thing will happen again. Now notice if you get 3 balls in a row, the lights blink and it gives you 2 points. And the wheel starts to spin, but let's say it gets stuck like this. Uh-oh. I think I might have actually broken it. Or not. Well, that's embarrassing. Let me fix that. Alright, well, that's just a little problem with Legos. Occasionally the gears will slip. And obviously I can't glue them, because if they ever actually broke, like they cracked, I wouldn't be able to replace them without tearing the whole thing to pieces. Getting a little more into detail about the inner workings. The music, you may be wondering, that's just the amplifier board. I bought that as a kit. I had to solder that together. There's the speaker. You can't see that very well. That's a RMP3 module made by Rogue Robotics. It has an SD card, and it's pretty much self-contained. All you have to do is send a simple serial command to it telling it what song you want to play, and it'll play that. You can also just use tones, which is how I did the beep 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 sound when you press the button to change the game mode. Actually, let me turn the volume up so you can hear it. You might have been able to hear it, but that's not a sound file, that's just a beep. These are Lego tank treads with these little pointy things stuck in them. And those little prongs, or pointy things, grab the balls at the bottom and lift them up to the top. And they all go up into there, where that thing feeds them out. Then they come out, they fall down, and they get caught, or not. And the cat comes and interrupts my video. They roll down this track. I'll just take a ball and demonstrate. They roll down this track. Tells the game that the ball has left the field so that it knows to feed another one. Or it knows that it hasn't left the field and to spin the wheel. There's also another way. Another thing that can happen sometimes is that thing will spin, but the ball won't actually be fed out for some reason. If that happens and the player knows that spinning the wheel isn't going to fix it, they can just press start and it'll just give you another ball right away. So you don't have to wait 10 seconds every time the ball gets stuck. It doesn't happen that often, but it does happen. So rather than redesign the entire game from scratch, I just decided to include a way for the player to tell it, hey, the ball didn't come out. Give it a little boot. So it just stays on GA1 or GA2 until you do something. Or until the cat bites me as I try to reach for the button. So yes, the wiring is kind of like a rat's nest, but I did use connectors to connect everything so that I wouldn't have to cut or unsolder wires in order to fix anything. Those little pieces of tape, like BX stands for ball exit. I know exit starts with an E, but that's how I referred to it in the program, so I figured, you know. The microcontroller that controls it is an Atmega 328P, controlled with the Arduino system software, or firmware, whatever you want to call it. And a shift register controls these LEDs. Well, actually, all the LEDs with the exception of the sensor ones. And the shift register also feeds the transistor that turns this motor on and off. And as for the ball feeding motor and the motor that controls this thing, those transistors are run off of the Arduino outputs themselves. And I did that so that I could use analog outputs to vary the speed of the motors. At full speed, the ball thingy spun way too fast to actually get any balls. They would just get pushed back or it would get stuck most of the time. So on this side of the board, I have a little connector there to use an FTDI cable to reprogram the game. This display is a SparkFun serial controlled LED display. It has a little chip on the back of the board. The board isn't that much bigger than the actual display itself. All you have to do is send it numbers. You usually send a reset command first to clear it, and then send the numbers in the order that you want to display them in. You can just use serial print for that, and use X for blank characters. And sending letters that can be displayed on a 7-segment display will just show up. And you can send it a dash and it'll show a dash like that. So it's pretty simple. I really like the SparkFun serial displays. So overall, I've enjoyed building this. I'm still not done with it because I'm going to build a wooden case so that I can actually move it from one place to another. I put 2 white LEDs. I got those from Radio Shack. The Legos, most of them I just had on hand, except for I bought one motor and the Lego tank treads from Lego Education. You can just Google that and you'll find the website in a snap. Some of the electronic components I got from SparkFun, others I got from Radio Shack. DigiKey had the connectors that I used. So, I didn't really plan out this machine beforehand. I just sort of tried a bunch of things by trial and error, like one step at a time. So, so I don't really have plans for this machine to give to you, unfortunately. And honestly, I don't think I'd want to just give away plans for this, honestly. Not to be rude, but I worked kind of hard on this, so. There's the board that controls the motors, and it also includes the voltage regulator, some filter capacitors, and a fuse. So you could call that the power supply board. The way I connected Lego motors to that is that I cut the end of the wires and stripped them out. And I used some Lego power extension wires to do this. I left the actual motor wires themselves untainted because when I was first building this, I didn't know if I was actually going to finish it, so I didn't want to ruin the motor wires and not be able to use them in actual Lego creations ever again. But I think I'm going to keep this for a very long time to come. And since I built it, I should be able to fix just about anything that'll go wrong with it. Or even just rebuild it again. In fact, I don't know, a million years from now I might build another one, but have it made, the board and all the stuff made out of wood. Or I might build a completely different kind of game with marbles in it. I used optical sensors because I figured they would be more reliable, first of all, and second of all, I figured it would be hard to find a physical switch that would work with something as light as a small glass marble. If I was using balls the size, if I was using metal balls that were the same size as pinballs, I probably could have gotten away with using a regular switch, but I probably still would have used optical sensors because, again, there's no moving parts to break if you use an optical sensor. And plus, as you saw, I can have the sensors recalibrate themselves every time and report any problems that might arise, if any problems ever do arise. Although, as you saw, mechanical problems are a lot more likely in a game like this. But the game has ways to report such things as well. For the most part, I'm pretty much done with this other than building a case. So there you have it. That's the game.